This presentation is an introduction to logic. First, let's look at a definition of the word logic. Logic is the systematic study of the principles of valid inference and correct reasoning. An inference is basically coming to a conclusion, and that conclusion must be based on facts known to be true or assumed to be true. The process of reasoning is to make sense of things by establishing and verifying facts. Reasoning helps us to think and determine things such as cause and effect, truths and falsehoods, and even what is good and bad. Now we'll define statement. A statement is a sentence that can be proven to be either true or false. The statement cannot be both true and false. It has to be either true or false. A statement cannot be a question. A statement cannot be an opinion. And a statement cannot be a command. So let's take a look at some statements versus some non-statements. The first thing we see here is Texas became a state in 1845. Well, that is a statement, and that is a statement because it could be verified as true or false. So it's a statement, and it happens to be a true statement. The second thing we see is Texas is not a U.S. state. Well, that's also a statement. But it happens to be a false statement because Texas is a U.S. state. So the thing to remember is that a statement doesn't always have to be true, but it has to be provable as true or false. The next one we see here, turn on the radio. That's a non-statement because it's a command. So we're told that it can't be a statement if it's a command, an opinion, or a question. So here's an example of a non-statement because it's an opinion. The best state to live in is Texas. Well, that's an opinion. That people who live in Texas may feel that way. People who have lived in Texas may feel that way. Or people who know people who live in Texas may feel that way. But it's an opinion because there are other people who don't think Texas is the best state to live in. And of course, this last one is a non-statement because it is a question. What is the best way to get from Atlanta from Nashville? It's a question. It's not a statement. These are the only two statements that appear on this page. One happens to be true, one happens to be false, and that's fine, but they're both statements because they're not a command, they're not an opinion, and they're not a question. Now let's look at the negation of a statement. The negation of a statement has the opposite meaning of the original statement. So whatever the original statement says, to form the negation of the statement, it has to be a statement with opposite meaning. So if the original statement is true, the negation has to be a false statement. And if the original statement is false, the negation has to be a true statement because it's going to have the exact opposite meaning of the original statement. So we have to learn how to write the negation of a statement. So here's our original statement. Texas became a state in 1845. Here's our negation. Texas did not become a state in 1845. Often you can just insert the word not and you can make a negation. But here's another way you can write the negation of the original statement. It is not true that Texas became a state in 1845. So once again, the negation must have the opposite meaning of the original statement. The original sentence is a statement about Texas becoming a state in 1845. These two negations say the opposite of that Texas did not become a state in 1845. So here's another statement. Texas is not a U.S. state. Now, and by the way, this is a false statement, whereas Part A was true, that Texas did become a state in 1845. That means both of these negations that we've written are false. This time, we start with something that's false. And because we're going to do the negation of this statement, our two negations will actually both be true statements. It is not true that Texas is not a U.S. state. Now that's sort of an awkward way to say it, but it means the opposite of Texas is not a U.S. state. It is not true that Texas is not a U.S. state. A better way to say this probably is Texas is a U.S. state. So in both cases you have an original statement and then the negation to mean the opposite of these statements. And in both cases of these negations, they're both true, but each time one is just a little bit easier to understand than the other, but you do need to know that it can be done in two different ways. We're going to be using symbols to represent both statements and negations. So in the kind of symbolic logic we'll be doing, we use lowercase letters such as P, Q, R, and S to represent these statements that we'll be reading and writing. The statement is that Texas became a state in 1845. Now let's look at the negation of that statement. That negation is written with this symbol that we call tilde. Tilde, actually. In most cases, you'll find it as the key to the left of the one key at the top of the keyboard. However, you will have to shift to get that shape, tilde. Now, this means not P. So what is the negation of P or not P? Well, Texas became a state in 1845. Texas did not become a state in 1845. So those are negations. One is true, one is false. Okay, let's look at another example. Texas is not a state. Again, we've used a lowercase letter, in this case Q, to make our statement. And our negation of Q, also known as not Q, is that Texas is a U.S. state. So those two statements, being negations, have to have the opposite meaning. So just as a review, Texas became a state in 1845 is a statement. Texas is not a U.S. state is a statement. In the first case, the statement is true. In the second case, the statement is false. But they're still both statements. In symbols, we will represent our statement by a lowercase letter. In this case, we write the letter P for our first statement. So the negation of P, that Texas became a state in 1845, is that Texas did not become a state, and that symbolically is written as tilde P. And that, of course, is a false statement in this case. Negations are not always false. In fact, this next negation is true. And we represent it by the letter Q, and its negation, or not Q, is tilde Q. Now we have to look at a different kind of statement. These statements are what are called quantified statements. Now, quantified means to associate some quantity or number with a statement. And these are going to be very vague numbers, but you'll see in just a minute. When you quantify, you use the word all, some, or none, or no. So all is a quantity. Some is a quantity, and none is a quantity. So here are some examples of statements that contain a quantifier. All types of vegetables are nutritious. So the word all in that statement is what makes it a quantified statement. Some pit bull terriers are dangerous dogs. Again, some is the word that makes it a quantified statement. No teacher is paid enough. The word no is the quantifier. And the last statement, some students are not dedicated to their studies. That's another kind of quantifying statement when you use the word some with the words are not. And quantified statements also have equivalent statements. So the first general type we saw a few minutes ago in our examples is all A or B. And we will rewrite this. There are no A that are not B. An example will make this much clearer. All types of vegetables are nutritious. So in this case, types of vegetables is our A, and nutritious is our B. So all types of vegetables are nutritious. So all A are B. All types of vegetables are nutritious. So in the next statement, we'll say there are no A that are not B. There are no vegetables that are not nutritious. Now, this is a little bit of an awkward wording and not the way that you would normally see this worded, but it is an equivalent statement. Here's another general type of a quantified statement. Some A are B. Its equivalent statement can be written as, there exists at least one A that is not B. So if only some are B, there has to exist at least one that is not B. Those are equivalent statements. Now, not negations, equivalent statements. They mean the same thing. Our example of some A or B was some pit bull terriers are dangerous dogs. Some A or B. It can be rewritten equivalently to say there is at least one pit bull terrier that is not dangerous, meaning that only some are dangerous. So our next general type is no A or B. And we will rewrite this as all A are not B. You'll see how this is equivalent. No teacher is paid enough. Now, in this case, teacher is our A, paid enough is our B. We want to rewrite this as all A are not B. So all teachers are not paid enough. Now that's a little bit awkward because we wouldn't normally say it that way. You could also say it as all teachers are underpaid because the word underpaid means not paid enough. And our last general type, some A are not B. So some A are not B can be rewritten as not all A are B. So our example is that some students are not dedicated to their studies. Some A is students are not dedicated to their studies. That's our B. We can rewrite this: not all students are dedicated to their studies. So instead of some, we'll use not all. Instead of are not B, we'll use are B. So, not all students are dedicated to their studies. Those two statements are equivalent. They mean exactly the same thing. So let's talk about the negation of quantified statements. So in our first column, we have our quantified statement, and in the second column, we have the negation of the quantified statement. Now remember, every statement has an equivalent statement, so these statements you see together are equivalent, but these statements you see across are negations or opposites of each other. All A are B, the negation. Not all A are B. All A are B can also be written: there are no A that are not B. The opposite of that is some A are not B. An example usually makes this easier. All tomatoes are red. Not all tomatoes are red. Those are opposites of each other. Another way of saying all tomatoes are red is there are no tomatoes that are not red. Once again, you're quantifying all tomatoes are red. If there are no tomatoes that are not red, then all tomatoes are red. However, look at the negation. There are some tomatoes that are not red. In one case we're saying they're all red, in the other case we're saying they're not all red. Our next type, general type of quantified statement. Some A are B. Our negation, all A are not B. This is the same as there exists at least one A that is not B. And this says that there's no A that's B. Again, example will make it clearer. Some tomatoes are red. No tomatoes are red. Those are opposite. You can't have some tomatoes red and no tomatoes red. Some tomatoes are red. All tomatoes are not red. Again, you can't have some tomatoes are red and then all tomatoes are not red. Those are negations of each other. There exists at least one tomato that is not red. No tomatoes are red. Those are negations of each other, because one is saying you can have a tomato that's red, the other is saying you cannot have a tomato that's red. So these statements are showing negations, statements that are opposites of each other. Now this is an example where knowing the negation of a quantified statement will help you to reason or understand the actual truth of what's going on. My 14-year-old son made this statement to me. I have completed all of my homework. The word all in this sentence is what makes this a quantified statement. However, I happen to know that my 14-year-old son does not tell the truth when it comes to his math homework. So I know the opposite of the statement to be true. And because I know he doesn't tell the truth, I can conclude that the truth is actually the negation or the opposite of what I was told. So if the statement is, I have completed all of my math homework, or in a simple way, all homework is completed. All A is B, where A is homework and B is completed. If I know the negation of the opposite statement is the actual truth, I can conclude the following. Some A are not B. Remember, A is homework and B is completed. Thus, I can conclude that some homework problems are not completed. If the negation or the opposite of the statement is true, that all A is B or all homework is completed, then I know that some homework problems are not completed. With practice, these will come to you more easily, but it does require practice to understand a statement, an equivalent statement, a quantified statement, an equivalent quantified statement, and the negation of either a statement or a quantified statement. With practice, this will become more natural for you to do. You'll understand the difference between a statement and a non-statement, a statement and its negation, and a quantified statement and its negation. And you'll also be able to recognize not just negations or the opposite of statements, but statements that are equivalent to the original statements. So each time you're doing a problem, you'll need to ask yourself, is it asking me for an equivalent statement, or is it asking me for an opposite or the negation of the statement?